All right, so opposite rays are two collinear rays, same endpoint, together form a line. So moving on to today's, we're going to be all about measuring segments. And to measure segments, well, we're going to start off with the ruler postulate because rulers measure segments. Yeah. Postulate 1.5, the ruler postulate. The points of a line can be put in a one-to-one correspondence with the real numbers. So think your number line as an example of that. So that the distance between any 2 points is going to be the absolute value of the difference between the corresponding numbers. So if we're looking at that number line, we have a set unit of how far apart the dots are, how far the numbers apart. But then if we took, say, if we're at 24 and we would know how far are we from 14, we would subtract those. And it's the absolute value, it's always going to be positive. So whether we're doing, like there, 24 minus 14, or if we're dealing with the negatives, 4 minus, say, a negative 10, or vice versa, it's always going to be positive. That's what the absolute value part is coming in. So think of this right here. So the length of a segment AB is going to be the absolute value of the coordinate A minus the coordinate B. So wherever we're at, take the one coordinate, subtract the other one, and it's the absolute value. Segments with the same length are called congruent. Use equal sign with the little wavy thing. The segment themselves doesn't necessarily have they can have a measure. But if we're talking about the segments themselves, we said they are congruent if we know that their measures are equal. So the measures can be equal, but the segments themselves are always going to be congruent. And that's going to be a lot of geometric shapes. We'll say that their measurement, their value may be equal, but if we're saying a square is the same as this other square, we would say the two squares are congruent, not the two squares are equal. So, like here, if we're looking AB, it's off the screen, sorry. AB may be 2 centimeters, same thing as CB. So we would say that their measures are equal, but the segments then would be congruent. And if you look real close there, you can see the two little lines. If I highlight these, there's a line here, line here, line here, line here. Those symbols there, the little tick marks is what they're called. The same amount of tick marks means they're the same size. So anything that would have 1 tick mark would be the same. Anything with 2 tick marks would be the same. 3 tick marks, and so on. So that works with angles too, but we're going to worry about angles tomorrow. So if we're looking at AB here on this little number line. So A, B, C, and D. So what is the measure of AB then? Let's start with that. Well, we would have the absolute value of A is at -8, minus then our B, which is at -5. -8 minus -5 is really -3, but because of absolute value, it makes it +3. So now if we look at BC, B, again, we know is at -5. Where is C at? -2. So -5 minus -2 is? -3. And absolute value of -3 is? 3. So, will they be congruent? Yeah. They have the same measure, so the segments would be congruent. Questions so far? All right. So, what do you think the distance of AC is? Well, let's find out. A is at -8. We would subtract where c is, which is at negative 2. Negative 8 minus negative 2 is? Which is 6. So what do you notice about that? I mean, up here we found the individual parts, AB and BC, which were each 3. Then we found the whole thing, which is 6. Right. So the parts sum together to get the whole, or the total. Which is what's leading into the next part here. We have the segment postulate of addition, which is really just saying that if we add up all the parts of the segment, it's going to equal the whole segment. So it's like if we find the distance from me to Garrett, and then we find the distance from Garrett over to McKenna, that should really be the same distance then if we just measured from me straight to McKenna. It's kind of common sense, but they still, you'll find in geometry, they have to state everything. So then you can use it and makes it a lot easier when you're doing proofs later on. So we're going to run into this stuff as problems like this. So dt is 60. So if we look at our deal here, dt is the full length. So we know the full length is going to be that. We also know that ds is going to be 2x minus 8. Pull the 8 over there. And then st is going to be 3x minus 12. And we need to find what x is. And then we're going to find ds and st. Well, knowing the postulate 1/6 there, their segment addition postulate, we know if we add the parts, it's going to equal the total. So that's where we're going to start. So ds is part of it, and it's a segment. We're going to add that to the other segment, which is st. And so total then we would get our dt. That's that segment addition postulate. If we add the segments, it'll equal the whole segment. For there, we're going to substitute in our actual values. So we know ds is 2x minus 8. We know st then is 3x minus 12. And we know dt is 60. From there, you're solving just a regular equation. So get your x's together. Is that Kale?
I need some marker boards.
Right there.
Excellent. Excellent. Okay. And I need a marker as well. Is that okay?
Don't the class you're in have markers?
No, well, we're in the lab right now.
Oh, okay.
But
Gotcha.
we gotta do something. I'll bring it back right away though. Okay?
All right.
See you, Mr.
See ya. Should have known the time we record, someone's going to interrupt.
Yeah. Hi, Kale.
Sorry, Kale. So if we finish this out, we can put our like terms together first. So 2x and 3x would make. And negative 8 and minus 12. It's going to equal 60. So add your 20 over. 5x would equal 80. Divide by 5. X is? How many 5's going to 80?
14.
Close. A little higher.
6.
One more.
60.
There we go. So, are we done? Usually when I answer that question, always say no.
No.
So, if we go back to the directions, it says, okay, so first we're going to find the value of x. But then it's going to want you to find what is ds and what is st. Don't just find the x and then move on. Always go back and make sure they don't want you to find more. So in this case, they want to know what is each of those individual segment lengths. So we're going to put it back in. So ds was 2 times our x, which is 16, minus 8. 2 times 16 is 32, and 32 minus 8. 24. Okay, and then st, we have 3 times our x, so 3 times our 16, minus 12. 3 times 16. Anybody got it? Close. 116 less. 48. And 48 minus 12? 36. So, way to check it. Make sure we're good. What's 24 plus 36? How much? 60. Which is what our total was, so we're good. We found the right stuff. So, a lot of these problems, you're going to go through, you're going to find the value of x, and then you're going to plug it back in to find the segments. Okay. So, questions with that? So, next thing we're going to hit is midpoints. Midpoint is just like what it sounds. It's a point in the middle of a segment. It's going to split the segment into 2 congruent segments then, so keep that in mind. It can be a midpoint, or that midpoint can be any line, ray, or even another segment besides just a point. That's going to split that in half. So if it is something else, usually we call that the, we'll call that the bisector, because it's going to split that segment in half. Bisect means to cut in half. Okay. So like here, point B is the midpoint, so it's going to split AC in half, so that AB and BC would be congruent. And then again, notice we have little tick marks also showing congruence there. So, knowing it's a midpoint allows you to find more problems like this. So, kind of clue word here is that C is the midpoint. So that tells you right now that it's splitting the whole thing into 2 congruent parts. That's going to be the big difference between the last problem. Last problem it said, hey, our total is this. When it gives you a total, think, okay, I need to add the segments, set it equal to the total. When it gives you the midpoint, you're going to set each segment equal to each other. So here we're going to find AC, CB, if AB, and AB, sorry. If AC is going to be 2x, and this plus 1 goes over here. And CB is 3x minus 4. So again, C is the midpoint of AB. So AC, CB would be congruent. So we'll set 2x plus 1 equal to 3x minus 4. So this is AC equal to CB. So when it talks about midpoint, you're going to set them equal to each other. When it talks about the total, you're going to add the 2 parts, set it equal to the total. Okay. From here again, it's just solving like a normal equation. Letters on one side, numbers on the other. So I'm going to actually subtract the 2x over. And then I'll add the 4 over. So 1 and 4 make 5. 3x minus 2x is just x. So our x is 5. And again, are we done here? No. We gotta go back, we gotta plug it in, we gotta find what AC, CB, and AB is. So let's start with AC. AC is gonna be 2x plus 1. So 2 times our 5 plus 1, which is 11. What is CB gonna be? 11. We said they're equal segments. So if you find one, the other one's going to be that as well. You're not going to have to find that twice. Even if we did put it in, 3 times 5 is 15. 15 minus 4 is still 11. So we found 2 of them, and then we need the whole thing, AB. Well, if we know each half is 11, the total would be 22. Any questions here? All right, that is the lesson.